By the end of this period, I want you to submit that document on Google Classroom with the people that were performing, okay, what they did, and what property it relates to. So that's by the end of the period. Right now, I want you to go to menti.com and enter this code, MENTI.
Oh, this website.
Yeah.
Menti.com.
I shared mine, can I just send it, it has all of our names on it.
Please enter code.
Shared what?
Just get,
32.
like it has all of our names on it.
Okay, that's fine. But what I want you to actually submit on Google Classroom is what other people did.
Yeah, I have that on.
Okay, yeah, that I want people to do that individually.
I thought you said it for percentage.
Yeah, so not what you did, but what other people did.
It says a code.
Yep, so code is 569732.
One property of gas.
What is one property of a gas? That's the first question. So it can be what you just saw moments ago, or it can be something that we talked about yesterday. Something from the slides, something from the book. I think it can be a phrase as well.
You could do a phrase, but like it shortens it to just one word.
It shortens it.
It takes out all the spaces.
Oh, okay. That's fine.
It says, please wait for the presenter.
Yeah, so there's a second question, but I just have to go over this one first.
It's like Kahoot before Kahoot,
It's like a Kahoot.
but less fun.
I want to see Patrick do my.
So something someone said in one of the groups, I don't remember, talking about liquids as a fluid, and that's true. Liquids are fluids, and gases are fluids also. But what's the difference between a liquid and a gas in terms of like talking about them as fluids?
Things like volume stuff, like the gas stuff. You know, I wouldn't write that.
They have an indefinite. They have an indefinite shape. The volume just takes whatever container it's in, right? So along those lines, what's the difference between a liquid and a gas? Yeah, me?
Not along those lines, but I remember you saying something about how gases, you're able to compress it together, but a liquid, you cannot, like if you have a water, you cannot compress a water bottle because it will just spring back up.
Perfect. So you can compress a gas, but you can't compress a liquid, right? That's what you said. And I think one of the people in a group that just presented said something contrary to that, so I just wanted to clear that up. You can't compress a liquid. You can compress a gas, even though they're both fluids, they have a little bit different properties. So on screen now, we can see the one word that most people have said is expanding. Other people said things along those lines, easy to expand, it's pretty much the same thing as expanding. Compress, compressible, compressed, all those are mean the same thing, just slightly different wording. No definite shape, yeah, that's a good one. No definite shape. Expand to fill container. Molecules move fast. You don't know. I appreciate the honesty. spread out, fill container. Yeah, so all those are pretty good ones. So the second question that I have for you is, what's the property of a liquid? Once again, it can be something that you just saw. It can be something that we went over yesterday together. One property of a liquid can be a word, a phrase. Adhesion, cohesion, good. Yeah, we talked about that yesterday. Not compressible. Yeah. Takes the shape of the container. Takes up volume. Not exactly sure what that means. Maybe it has volume. Like, okay, I think that's what that means. Liquid is a fluid, can change to any shape, that's true, yeah. Fixed volume, but no fixed shape, yeah. Filling container, fluid, incompressible, drinkable. If something is a liquid, does that necessarily mean we can drink it?
Because hydrogen
You can't do peroxide.
Can't drink peroxide. Do you want to drink gasoline? Probably not.
If you survive.
So just because you can drink something doesn't mean you should. Yeah. So they said they did qualify it. They said for some, at least.
You can't see who put the answer there?
Nope. Although I can guess, Isaac. I can guess.
No, I had a good one.
So, who remembers what adhesion and cohesion are?
I wrote it down.
Is that like sticky and
One
stuff?
is like sticks to
So it has to do with sticking. Italian?
And adhesion sticks to others.
Yeah. Cohesion, the substance sticks to itself. Adhesion sticks to other substances. So, do you remember any examples?
Adhesive tape.
like
So, adhesion and adhesive are slightly different things.
on the window.
Hey,
They
tell my example.
drop to form on big ball.
Okay, so what is that an example of?
Or adhesion, right? 'Cause- no, that's cohesion because it's sticking to itself.
Right, so the water droplet is sticking to itself, right? So it's holding its shape. How about adhesion? Okay.
Water to your skin.
So water sticking to your skin is both adhesion and cohesion. Any other examples? Wendy? Yeah, so adhesion is when something sticks to something else. Do you remember a specific example that we went over? Maybe in a lab that we've done, or just like something you might have seen in everyday life.
We said something yesterday about the M&M lab that we did, about how if you take tissue paper and then you dump it in the water is going to be absorbed into the tissue paper, right?
Mm-hmm. Yeah, so if paper towel gets wet, right, the water is going to have an attraction for the paper. It's going to travel throughout it, and through capillary action, it's going to spread. Right, that's adhesion. Good. Okay, so we're going to switch gears and go over a lab that we're going to do tomorrow. We're going to use a petri dish. Does anyone know what a petri dish is?
They put bacteria in it
It's the
sometimes.
thing, the brown seed.
Yeah, so it's one of these, has a bottom lid and a top lid. And there's going to be 5 different experiments that you're doing. In the petri dish, they're separate. So after each experiment, you're going to have to rinse it with water and then clean it and dry it. So you're going to have your data table. In experiment 1, you're going to have, well, in each experiment, you're going to have substance A and substance B inside of the petri dish, and substance C is going to go on top of the lid. So, for example, in experiment 1, you'll have 1 drop of water that you'll get using, what do you think you'll use for a drop of water?
A pipette.
So you use a pipette with nothing else, and then ice cube's gonna go on top. Okay, you'll wait a few minutes, observe the inside surface of the top, the inside of the top, so like the inside of this lid. You'll see what it looks like and record your observations. You do that 5 times. Each experiment's slightly different. Experiment 2 is a drop of water inside with a drop of water on top. Third experiment is rubbing alcohol inside with a drop of water on top. So each of these are a little bit different. And then you have an experiment 4, you start using calcium chloride, right? Just some salt, and observing what happens there when you mix it with either a drop of water or you put an ice cube on top. What effect does that have on the solid? Okay, so as we were talking about yesterday, we're going to investigate some of the intermolecular forces of liquids. And real quick, just like a very basic summary, who could tell me what an intermolecular force is? Pat?
Something is in between two things.
Something is in between 2 things.
Force is between two things.
A force between 2 things. Yeah. And what does that force do? What is that? So it exists with liquids and solids. But let's say for liquids, what does that intermolecular force help the liquid to do?
To move.
Okay, it might help it to. I wouldn't say react. Maybe to move. But what else?
Collision.
Like, does it help?
Maybe.
Does it, like, if you have droplets of water, does it help it pull together?
Yeah. Intermolecular forces help keep the liquid together, which gives it its definite volume. Gases don't really have intermolecular forces. That's why there's no definite volume, and they're very like spread out, as we saw with the demonstration today. I think someone like ran into my desk. Hope you're okay, whoever that was. Yeah, so with those skits and the Menti questions, those were focusing on properties of gases and liquids. This lab looks at liquids and solids, so you kind of get to see all of the phases.